Let's look at question C from the multiple choice section of Math 2017. So we're given a sequence AN with a property such that AN plus 1 is equal to AN over AN minus 1. And that's for n greater than or equal to. We're told that the first term in the sequence is 2 and the second term is 6, and asked to find the value of the 2017th term. Okay, and they're giving us some options: a sixth, a third, a half, 2 and 3. So we can look at what we've been given here, this kind of property of the sequence. We could start playing around with the algebra here and trying to do something. What we could do first, and what's always a good idea in sequence questions, is just to stick in some values and see how the sequence builds up. And it might help us with the idea of what pattern's going to be. So it's definitely not a bad thing to start seeing what the next term is. So let's look for A3. Well, it's A2 over A1 by this formula. And we know what they are. They're just 6 and 2. So it's 6 over 2, giving us a 3. What about A4? Well, it's A3 over A2, which is now 3, the one we found out last time, over the 6, or a half. Similarly, A5 is now a half over 3, or a sixth. A6 is a sixth over a half, so now that 2 gets multiplied by the sixth, give us a third. A7, we can find again similarly, a third over a sixth, or 2. And what about A8? Let's go one more. We're back to 2 over a third, giving us 6. So notice how when we got to A7, we had 2 again, which was A1. And A8's given us 6 again, which was the same as A2. So A9 is just going to be exactly the same calculation as A3. It's going to be 6 over 2, giving us 3. And then so on, like A4 is going to be, well, A10 will be the same calculation as A4. So it looks as if these numbers are going to repeat every 6. But we can show that this will be the case by looking at the formula we're given here. So AN plus 1 is AN over AN minus 1. So if we write that out here, and now think about AN. If we use the formula within itself, if AN plus 1 is AN over AN minus 1, then AN can be written as AN minus 1 over AN minus 2, like this. So we can put that in there, and that simplifies down to just 1 over AN minus 2. So kind of every 3 terms should be the reciprocal of each other. So let's check we're getting that. And look, A1 is 2, A4 was a half, but then A7 was 2 again. So that is happening. A3 is 3, A6 is a third, so the terms are reciprocating. Let's go one step further and now substitute that formula in for this AN minus 2. Well, first we can use this again here. So AN plus 1, if we reduce the index down by 3, is AN minus 2, and this becomes AN minus 5. Now let's stick this into here, and we can see then that AN plus 1 is just AN minus 5. So indeed we can conclude the sequence is repeating every 6 values. Okay, so now that we know that, it's just a matter of deciding that, given that the first term is 2, and then we know the next 6 terms, what the 2017th term will be. So how many 6s in 2017? Well, you can divide it in. 6 into 2, 0. 6 into 23, remainder 2. 6 into 21, 3, remainder 3. 6 into 37 is 6 and remainder 1. So it's 336 and a little bit. It might be 336, remainder 1, remainder 2. What we can do to be sure is multiply 336 by 6 to see how big this gives us. I mean, without a calculator and without doing long multiplication sort of thing, the fastest way I can think is do the 333 by 6, because you know that that's just 2 less than 2,000, because 3 lots of them is 999, and then add the remaining 18. You've got 3 6s left. So if you do that, you'll get 1998 plus 18, or 2016. So that means that whatever the 2016th term would be, it needs to be the same as the 6th, the 12th, the 18th, and so on and so on and so on. So, for example, it's the same as the 6th term, or it's a third. And that means that the 2017 term will be equal to the next one, or the 7th term, which is just 2. So we can conclude our answer is D.